Okay, so I know this is late, but I figured this might be helpful for some people. I saw some people were doing the extra practice, so I'll go on ahead and record some of the proofs if you'd like to watch that again. Just give me 1 second to get my iPad connected. Great. Okay. So there's a couple proofs in particular that I'm going to go through. Um, Mostly the this proof right here. So we'll start with this one. And again, if I want to prove that something bisects, basically what that means is I want to prove that these angles right here are equal. So IST is equal to CST. So what I was getting at today is that IST and CSC are in two triangles. They're in these two, but they're also in these big ones. And so there's two options we have to prove prove the angles equal. We can CP/CTE from these ones, or we could CP/CTE from the big ones. And so let's look at our givens to see what it gives us first. So it tells me that CIS is equal to ICS. It also tells me BIC is equilateral. And it also tells me BS is straight line, but I don't really use that given. So I'll mark that CIS, which is here, is equal to this one. And then BIC being equilateral tells me the sides are equal. Now, I do need to say that they're equal by the definition of equilateral, and that is by line 2. Great. And then from there, I can also see that IS is equal to SC because of equal sides, equal angles. Or sorry, equal angles, equal sides, and that's by line 1. Great. So now if you notice, I already have two sides of the bigger triangle. So if I prove that this triangle right here is equal to this triangle right here, I get to say, and once I IDBS, that triangle BIS is equal to BCS by side, lines 3, 4, and 5. You might say, okay, why is that helpful to us? Because if I prove that these big triangles are equal, even though it doesn't extend all the way to B, the pink and the blue are still inside that bigger triangle. And so I can still say that angle IST is equal to CST CBCT, and because these are then equal, well, since they're equal, I know that BS has to go through it. So BS bisects angle ISC by the definition of bisect. Because again, bisect just means you have two equal angles, which I do there. Now, there's another option you could do. You also could have said these angles are equal by equal sides, equal angles, and then done equal plus equal here and proven these triangles equal by SAS. I think side's a little easier here. But if you did it that way, it's also a viable option. Great. Here's the fun one. Okay. So I'm gonna add another proof in here. I want to prove that HOY is equal to triangle HAY. And you might say, okay, why are you adding that in? Well, it's in the hint below, but also because if I want to prove that this triangle right here is equal to this triangle right here, that's a smaller triangle inside a larger triangle. So kind of like when we did the prop 5 proof, which is equal sides equal angles, it's going to be kind of like that. Our strategy here is going to be to prove that these triangles are equal here. And then kind of like the last one, the bigger triangles gave us these angles right here. So the bigger triangles will give us these angles. You might say, okay, well, why is that helpful? We'll see in a second. So again, I'm going to add another 2 proof in there. We have YO is equal to YA by given, and I have angle HOA is equal to HAO, also by given. So I have YO is equal to YA. I have HOA is equal to HAO. And then we'll kind of go from there. So I'm going to go ahead and mark that these are equal because of equal angles, equal sides, line 2. And then I can actually, once I do that, go ahead, IDHY, and I get my first proof. Triangle HOY is equal to triangle HOY by SSS, line 1, 3, and 4. So again, let's go up and I'll shade those in so we can kind of see it. Here's the first one. And then here is the second one. We just proved that the blue is equal to the green. Now, if you look at this, although this full triangle is not fully inside the other one, so we can't just CPC the whole triangle, what I can do is, if you notice, these sides are in that larger triangle. These angles, this side, these angles, this side, these angles here. Those are all equal by CPCT because the triangles are equal. Again, corresponding parts of congruent triangles are equal. Once the triangles are equal, then all the sides and angles are equal. So there's some sides that are helpful to us. Take a few steps back. These are going to be helpful to us because they're part of the little triangles that we want. So I'll go on ahead and mark those equal by CPCTE. And then what that allows me to say, once those are equal, I don't know ASA yet, but I can ID this, HX, and there's my side, angle, side. And I did exactly what I wanted to do. And that's it. Triangle HOX is equal to HAX by SAS, line 7, 6, and I think it is 3. Okay. Hopefully those videos are helpful. I can go through these kind of quickly. So I think these proofs, most of them are pretty self-explanatory. You've seen stuff like that before. For this one, KL is equal to LJ, CB is equal to BA. Now, since they're separately equal, I can say that all these angles are equal. Or sorry, I can say that the angles and the triangles are equal to each other, not all of them. So J sometimes equals L, K always equals J. C always equals A. So then this is a never because we know that C is equal to A always. So then it's not going to be equal, never. And L is equal to B sometimes. Great. K is equal to C. J is equal to A. Now notice those are not in the same triangle. Because they're not in the same triangle here, you don't know anything. Sometimes, sometimes, sometimes. Now, I don't have enough information to say the triangles are equal either, so that's also sometimes. Great. Hopefully this was helpful.